Okay, guys, here we go. This is a lesson on multiple angle identities. You can follow along in your textbook, page 384 to 389. We are going to be learning about a few different identities and formulas here. Double angle formulas, power reducing formulas, and half angle formulas, along with a few examples. Right now, what I'd like you to do is pause this video, make sure you have something to write with, some paper, and I think that's about it for right now. Why are we learning this stuff? Well, these formulas can help us rewrite very complicated trigonometric equations and solve them, making them into something that's more convenient for us to use. Throughout this video, what I'm going to be doing is I'm going to be inserting some places where you have to write something down, and that's what I'm going to be checking on Monday for your notes. So make sure that you're paying attention, stay focused, stay with me, and let's get going. Okay, we're going to begin with double angle formulas. However, before we start, if your last name begins with the letters from A through H, what I'd like you to do is write down the letters PMA for positive math attitude. Okay, I'll be checking that in your notes. If your last name begins with A through H only. The rest of you don't need to write it down. Okay, our double angle formulas, and this is on page 384 if you're following along. We've got sine of 2u, 2 times some angle u, is equivalent to 2 sine of u times cosine of u. These two expressions are identities. They are they're interchangeable. So that's identity number one. The second one that I'm going to write down is the cosine of 2u. Now the cosine has a few different identities that we can use. One of them is cosine squared u minus sine squared u. It can also be written as 2 cosine squared u minus 1. I want you to think about how these can all be derived from one another. And then 1 minus 2 sine squared u. As we're going through this, make sure that in addition to anything that I ask you to write down, that if you have any questions whatsoever, pause the video, write it down, because we want to make sure that those questions get answered. Okay, so those are the double angle formulas for cosine. And last but not least, tangent. If you have tangent of 2 times some angle u, it can be replaced with 2 tangent of u over 1 minus tangent squared u. Okay, those are the formulas that we're going to be using, and we're going to use those to solve problems that have double angles in them. Okay, so what I want you to do right now is note the time. It is 3 minutes and 21 seconds into the video. Write that down, and this is the time when I'm going to tell you a really hilarious joke. Okay, so why couldn't the angle get a loan? Because his parents wouldn't co-sign. Ha! All right, next. We're going to be solving an equation, so let's, again, pause the video, write down this equation. 2 cosine of x plus sine of 2x equals 0. We're going to solve this for all x in the interval from 0 to 2 pi. Okay, if your last name begins with the letters I through, let's say, T, I want you to write down, I love trig. All right. Okay, then let's get going on this. So why am I using this example in this lesson? Well, it's because of this guy right here, 2x. That's a double angle. So what we're going to do is we're going to use this identity, whoops, right here, and I'm going to replace sine of 2x with 2 sine of x cosine of x. So, whoops. So here we go. So we're going to leave the 2 cosine of x as it is, plus 2 sine of x cosine of x. This is just an identity that I'm using. This whole expression right here is identical to 2 sine x cosine of x. All right, so then what we want to do is look at this. This is now going back into lesson 5.3, solving equations that don't have double angles in them. What do you notice in both of the terms? We can factor out a cosine of x. Actually, we can factor out a 2 cosine of x. And then left inside the parentheses, we'll have 1 plus sine of x equals 0. So we use the double angle identity. And here we're factoring out 2 cosine x from both of the terms. And now what we're going to do is use the zero product property and set each of these factors to 0. So 2 cosine of x equals 0, and 1 plus sine of x is equal to 0. And I'm going to solve both of those equations. So dividing by 2, I get cosine of x is 0. And in the interval from 0 to 2 pi, where is the cosine of x equal to 0? Hopefully you got that down. Uh-oh, I'm writing over myself. So cosine of x equals 0 when x is, pause the video and write it down, and then check back. Cosine of x is equal to 0 at pi over 2 and 3 pi over 2 in the interval from 0 to 2 pi. And then we're going to set this, we're going to solve this equation over here by subtracting 1, so I get sine of x equals negative 1. And where does sine of x equal negative 1 in the interval from 0 to 2 pi? The answer is at 3 pi over 2. So the answer here for x in the interval from 0 to 2 pi is pi over 2 and 3 pi over 2. All right, if you had any questions on that, make sure that you are asking. Okay, so now I'm going to give you a little quiz. I want you guys to write this in your notes. So right now, pause the video, write this equation down, and I want you to use your double angle identities to replace sine of 2x, and then go from there to solve this for x on the interval. We'll just stick with from 0 to 2 pi. Okay, you guys do it. Pause the videos, write the problem down, solve it, and come back to check your solution. Make sure that you're doing it correctly. Okay, so we start out with the double angle identity, replacing sine of 2x with 2 sine of x cosine of x. Then next I factored out the sine of x because I have a sine of x common to both terms. Then I use the zero product factory and set each factor equal to 0. Sine of x equals 0 when x is 0, pi, and 2 pi. And then I had 2 cosine of x minus 1 equals 0. So I added the 1 and divided by 2, and now I'm trying to find where does cosine of x equal 1/2. And that is when x is equal to pi over 3 or 5 pi over 3. So the solution is, in order, 0, pi over 3, pi, 5 pi over 3, and 2 pi. Okay. So the next thing that I want to look at here is double angle identities. They are not restricted to angles in the form of 2 theta. For example, we can apply the formula to sine of 4 theta or cosine of 6 theta. So sine of 4 theta would look like this. We would do the same kind of thing. It would be 2, not cosine, 2 sine of 2 theta, because we're going to split this angle in 2, cosine of 2 theta. And then if you look back at your cosine identities, you can pick any one of the 3. I'm just going to pick the, I'll do the one cosine squared u minus sine squared u. So what we have here is cosine squared instead of u, we're going to take half of this angle, which would be 3 theta, and then minus sine squared of 3 theta. So the point is you can apply it to any angle that is multiplied by a factor of 2. Okay, so if your last name begins with U through Z, I want you to write down this number, 3.14159, in your notes. Okay. And another joke. So, Why did the obtuse angle jump in the lake? Waiting for it. Okay, well, because it was so hot, it was over 90 degrees. Obtuse angle dance, obtuse angle dance, obtuse angle dance. All right, let's look at our power reducing formulas. Write these down in your notes. Sine squared u equals 1 minus cosine of 2u divided by 2. That's one of them. Let's put it in a box. And we have cosine squared u equals 1 plus cosine of 2u over 2. Second one. And the last but not least, tangent of tangent squared u is equal to 1 minus cosine of 2u divided by 1 plus cosine of 2u. All right, it's nice if you can memorize these identities. I will allow you to use notes for your test on this topic, but if you have them memorized, it makes things a whole lot easier. Okay, and right from here, I'm going to go right to the half angle identities. And we have sine of u half of an angle, so u divided by 2, so if the angle is u and it's being halved, it is equivalent to plus or minus the square root of 1 minus cosine of u divided by 2. That's one of them. And these can all be derived from the previous power reducing formula. We'll go through that on Monday. I'll show you how to do that. The half angle identity for cosine of u divided by 2 equals plus or minus the square root of 1 plus cosine of u over 2. And then tangent of half of an angle u is 1 minus cosine of u over sine of u, or it is also equivalent to sine of u over 1 plus cosine of u. Okay, I want you to write down the time. It is 12:28. The next joke is, what do you call a man who spent the entire summer on the beach? A tangent. Tangent. Ha. All right. Anyway, let's pause the video, write down this example, and I'm going to go through this, and then we'll be done. Okay, so 1 plus cosine squared x equals 2 cosine squared x over 2. What I'm going to do is I'm going to leave this side alone, and I'm simply going to use my half angle identity. Recall that cosine, I could rewrite this as cosine of x over 2, that quantity squared. So I'm going to use my half angle identity on this, and it's going to become plus or minus, look at your identities, 1 plus cosine of u over 2, that quantity squared. Now I have a square root being squared, so this becomes 1 plus cosine squared u equals 2 times, when I square this, I'm going to get 1 plus cosine of u over 2. As I distribute the 2, I'm going to get 1 plus cosine squared x equals 1 plus cosine of u, I'm sorry, x, not u, these are all supposed to be x's, sorry about that. Okay, x cosine of x, and now I can subtract 1 from both sides, and I'm going to get cosine of x equals, cosine squared x equals cosine of x. And here we go. If I subtract cosine of x from both sides, I can factor out a cosine of x, and I'm going to get cosine of x minus 1 equals 0. And you can set each of these equal to 0. Cosine of x is equal to 0 at pi over 2 and 3 pi over 2. And cosine of x, if I add the 1 to both sides, it equals 1 when x equals 0 and 2 pi. All right. All right, done. I'll see you on Monday.